Good morning, students. Today we will cover MTL for deep learning. Is multitask learning using deep learning. Essentially, deep learning supports multitask learning, uh, explicitly or implicitly depending on the type of model. And the two approaches that were introduced earlier, that is the hard and soft parameter sharing, are employed by deep learning to support multitask learning. Deep relationship networks in MTL for computer vision. For computer vision, it means where computer can recognize images. Approaches often share the convolutional layers, while learning task-specific, fully connected layers. Here, the main model in deep learning for computer vision is CNN, convolutional neural network, that has convolutional layers and fully connected layers within CNN. Convolutional layers for the purpose of learning the features, and fully connected layer for the purpose of classification. Um, this paper 38, which is mentioned in the references of this article, improve upon these models by proposing deep relational networks. In addition to the structure of shared and task specific layers, shared and task specific layers, they place matrix pairs on the fully connected layers. And this allows the model to learn the relationship between the tasks, which may be adequate for well studied computer vision problems but prove error prone for novel tasks. This is the architecture known as deep relationship network. This network has been designed um, to implement computer vision tasks, okay, which are many in number. There are shared layers and uh, there are task specific layers. Observe this illustration. This is the input. These are convolutional layers, and here, and this is convolutional structure that learns somewhat generalized representation. From that point onwards, it can learn more about specific tasks. Okay, this is one, and you can have two, three, four, and up to n. And here, what happened is these are fully connected layers. These are convolutional layers. They somehow learns the generalized representation for all the tasks, and then followed by this fully connected layer for specific task. So this one is a fully connected layer 1 for task 1. It is learned, task 1 is learned and then classified. This from task 1 and so on up to task n. This is deep relationship network. Another model is fully adaptive feature sharing. Article 39 in the reference section of this one propose a bottom-up approach that starts with a thin network and dynamically it widens it greedily during training. And the criteria is that promotes grouping of similar tasks. Consider this figure, this round 1, round 2, round 3. Three boxes represent three different rounds. And here, this is layer L, L minus 1, L minus 2. As the round progresses, this layers get widened. Here you have only one layer. Here it is widened into multiple, um, you know, components that supports learning of the tasks. This round 3 further the division occurs at layer n minus 1, L minus 1 as well. Initially at layer L, followed by L minus 1, like this process may continue. This is how um, the network learns multiple tasks. Another network is cross stitch network. This 40 reference paper uh, presented two separate model architectures like um, in soft parameter sharing, and they use what is referred to as cross stitch unit that allows the model to determine in what way the task specific networks leverage the knowledge of the other task by learning a linear pattern after pooling and fully connected layers. This one is the cross switch. Here there is network A and there is a network B. Network A uh, performs learning of task A. Network B performs the learning of task B. And there is a cross stitch. This cross stitch is implemented in between these network designed for specific tasks. This cross stitch supports uh, learning, of representations from other network designed for other tasks. This both this green one will learn from pink, pink will learn from green one. Low supervision. In NLP, so far we learned about in computer vision how multitask learning through deep learning takes place. In contrast to what was learned in computer vision, NLP, natural language processing, finds better task hierarchies for multitask learning. NLP tasks typically used for pre-processing, such as part of speech tagging, name entity recognition, should be supervised at lower layers when used as auxiliary task. There is a primary task and there are auxiliary tasks. In multitask learning, these parts of speech tagging, name entity recognition, they can be supervised at lower layers and used for um, auxiliary learning task. This architecture shows multi joint many task model. And then paper 42 predefined a hierarchical architecture consisting of several NLP tasks, which is shown in this figure as a joint model for multitask learning. This POS tagging, chunking, and then this is entity, named entity recognition. Alright, this one is uh, a determiner. Then relatedness encoder, relatedness, entailment encoder, entailment at word level, at syntactic level, and at semantic level. This processing is done at these various levels. Weighting losses with uncertainty. Instead of learning the structure of sharing, there is an article numbered 43. Take a orthogonal approach by considering the uncertainty of each task. And later they adjust each task's relative weight in the cost function by deriving a multitask loss function based on maximizing the Gaussian likelihood with the task dependent uncertainty. This is the figure. This input, this encoder, the semantic decoder, instance decoder, depth decoder. After encoding, various parts of the image is decoded and task uncertainty is measured for each of these various components. Finally, these values summed up to find the multitask loss. Tensor factorization for MTL. Uh, the there are works, research work uh, that seek to generalize existing approaches to MTL to deep learning. This reference 44 generalize some of the previously discussed matrix factorization approaches using tensor factorization to split the model parameters into shared and specific task specific parameters for every layer. This Swiss network, this was proposed in paper referred by 45 number, and this model generalizes deep learning based MTL approaches based on hard parameter sharing and cross-stitch network, block sparse regularization. This figure 8 present that model. This all the concepts have been combined together to create a model here that performs the learning, multitask learning. Okay, that's it about multitask learning. Multi-view learning we will look at in the next class.